All right, here we're supposed to find a linear regression model for the data on average annual precipitation as shown in table 14 there, where X is years since 1960 and Y is the precipitation in inches. Now the equation we get is supposed to be round the coefficients to 3 decimal places, and then we're to use the model to estimate the average annual precipitation in the contiguous United States in 2025. So, key thing here, since 1960. All right, well, it says in 65, 75, well, 65. So what we're gonna have to use is X is 5. Here, 10 from that is 15, and 25, and then 35, and 45, and then 55. And we want to know in 2025, which is going to be another 5 years from that. And so that's going to be in 65 years since 1960. So that's the first key. We're not going to use actual year numbers. So whenever you're doing something, it's usually going to be since some point in time. And so we'll use this values instead of the actual years. Now, in this one's, we need to use this column because we want the average annual precipitation rather than this column, which is the annual average or average annual temperature. So we need this column and our one we made up here. And so what we're going to do is we're going to go to our calculator and we're going to clear everything out and clear out. And here we're going to clear out and here. And I was typing this in so we didn't have to have as much time to spend typing it in, but we're just going to type in that table where the X values since 1965, 15, 20, 20, all that, and then our annual average precipitation. So that's what we get. And so if we go to our window, what I would probably do is go from 0 to, in this case, remember, we want to have 65 in our value. So I would go to 70, okay? Because we need to have 65 for sure because we want 2025 years, the year 2025. And then our Y's, we're going to go between what was it, 29.8 and 34.59. So, and when you do the zoom, it actually, what it does is it takes you to that. But if I do the zoom again, I went ahead and changed it to 70. The zoom would actually put this out a little further. So that would be about here, but we need that 2025. Now, what do we need? Well, now we need to find a linear regression. So again, we're going to go to stat over arrow, and then we're going to have for linear regression. So L1, L2. Now we can put the variable here. And so we have vars, and we go 1, 1, and we hit enter, and we hit enter. All right, so this is going to be our answer. And so what we would have then is 0.051 is going to be our value before the X. And then we're going to have 30.166 as far as the next value goes. And so that would be that. Now, is the fit, very good? Yeah, it's still not a super good fit, but what does it look like? Well, that's what it looks like, okay? So not bad, but it's one of those where we have actual scatter in our data. And so that's kind of what it is, but that's the best fit line for this data. Now, it also asks, what is the annual precipitation in 2025? All right, well, how do we get that? Well, that's going to be this number somewhere out here. And so we need to go and do second trace, and we want a value. And we said that was 65 years since 1960. And so that means it's going to be 33.48 inches of rain. Okay, so now we've got everything we need. So now we just have to go back and write it all down. So what do we have? We have our equation, which is going to be, what do we want to say? X is your, and okay, so we're just using X and Y. So Y is equal to, and we said that was 0.051x plus 30.166. And this is going to be average annual precipitation. In X years since 1960, okay? And it's going to be in inches. Okay, so that's what it was going to be. And then we wanted to know what y of 65 was, and we plugged that in and did our second trace and did a value, and we got 33.48 inches in 2025. Okay, so that was how we would figure this one out. And again, there are multiple ways, but that would be the easiest way to get first to our equation. And then we could see on our graph of our line, it drew a nice line. And then after that, what we could do is we could plug in 65 in the value, and it gives us a 33.48 inches. So hopefully that helps you with at least how to type it in your calculator, find an equation, and use that to actually answer another question within the equation.